welcome to True Projects. In this video, we are going to explain about the project that is a runtime framework for ensuring zero trust state of client's machine in cloud environment. So before getting into the execution, first let us understand what is this project about. Cloud computing is basically how a lot of businesses and applications run today. Instead of buying and maintaining expensive servers, companies can just rent computing power and storage from cloud providers like Amazon or Google and pay only for what they use. It is super flexible because they can scale up or down depending on their needs. For example, a hospital might need a lot of resources one day and less the next. This is why so many sectors, from healthcare to enterprise management, are moving away from traditional servers to cloud servers. But all these benefits come with some risks also. That is serious risk. Since your data is stored somewhere else on someone else's servers, you lose a bit of control over it. Hackers or even internal employees could potentially access or change your data without your knowing. Regular security tools like antivirus programs don't always catch new threats, and hardware protections aren't always practical in cloud setups. On top of that, the old security approach of everything inside the system is safe doesn't work anymore because cloud systems are shared by many users. This makes keeping data private and secure a real challenge. And here, one of the biggest challenge in cloud computing is spotting problems as they happen. Threats like hackers or malicious software can stay hidden for a long time before anyone notices, which can cost a company a lot of money and disrupt their operations. Small mistakes like leaked passwords, open network ports, or softwares that hasn't been updated makes this even worse. So researchers shows that for a medium-sized organization, it can take months just to figure out that a system has been compromised and then even more time to fix it. This clearly shows why it is so important to constantly watch over cloud systems and catch problems early. Continuous monitoring and early detection helps to maintain trust and keep the system secure rather than waiting until something goes wrong and damage is already done. So to overcome with all such issues, this project sets up a local cloud server to act like a mini version of trusted public cloud, that is TPC. So the main idea here is to use zero trust principles, which means the system doesn't automatically assume anything is safe. Instead, it constantly checks the client machine to see if anything has changed or been tampered with. Because we don't have access to real cloud servers, all the monitoring and verification happens locally on our system. Whenever the system detects something unusual or unauthorized, it immediately alerts the users so they know something might be wrong. This way, even without a full cloud setup, we can simulate how zero trust security would work in practice. So, the proposed system has few key parts that work together to keep local cloud environments secure. So, first, the kernel module keeps an eye on the system and tracks changes to files. Whenever a file is opened or modified, it creates a unique fingerprint called hash and stores it in a special memory buffer. This way, any unexpected changes can be detected quickly. And then Trust Agent. Trust Agent, it reads the file hashes from the buffer and works with a software-based TPM to verify them. It uses a queue system to efficiently process each file's hash, making sure nothing suspicious is happening. And then Software Trusted Platform Module. It acts like a virtual TPM, performing the cryptographic checks that a hardware TPM would normally do. It helps to securely verify file integrity and manage encryption keys, even though we are running everything locally. And here, verification cluster. So, this double checks the measurements from the client's machine and it allows users to decide which files to verify, to include, exclude. So, unnecessary checks don't allow the system down. Every file is encrypted and hashed with private keys to ensure that it doesn't being tampered with. Together, these components create a practical zero trust setup that monitors the system in and keeps files secure. Moving on, in addition to monitoring the client machine for changes, the extension keeps track of what users are doing. So here, every action taken by user is recorded, which allows the system admin to see patterns of behaviors. For example, if someone is trying to log in repeatedly or guessing passwords, the system will show these suspicious activities. This gives the admin a clear way to identify users who might be attempting to compromise the system. Once the admin has this information, they can take preventive action. By analyzing logs, the admin can block users who are behaving maliciously, stopping them from making further attempts to access or manipulate the system. This not only protects the cloud environment from potential attacks, but also ensures that legitimate users can continue using the system safely. Essentially, the extension adds a layer of user level security to complement the machine monitoring, making the overall system more robust. So the first module we have is the admin module, that is admin login. This module allows the admin to access the system using a predefined username and the password. Once logged in, the admin can view the activity logs of all users to monitor for suspicious actions such as repeated failed login attempts or unauthorized access. The admin can also block users who are found to be engaging in malicious behavior, helping to secure the cloud environment. Then comes new user sign up. So this module lets new users register to access the cloud system. By signing up, users create their own credentials, which will allow them to log in and use the cloud services securely. Cloud VM user login. So once user has signed up, this module enables them to log in into the system using their credentials. This ensures that only authorized users are having access for the cloud services. Then we have upload file. So after logging in, users can upload files to the cloud. Each file is first encrypted and assigned a hash to ensure integrity. Users can also select a verification type, either include or exclude, giving flexibility in managing computation overhead. Then we have verify and download file. This module allows users to check the integrity of their files before downloading. It compares the current file's hash with the previous hashes in the chain. If the hash matches, it confirms that the file has not been tampered with, ensuring secure retrieval of the cloud. And the last one we have is the file verification graph. Last one will be displayed with the verification graph. So to implement this project, basically we need hardware and software requirements. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software requirements are application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is all about the overview of the project. Now let's execute. To execute, let's open the code folder that contains source code files. These are the source code files of this project. So the first folder is a static folder. This folder contains files related to CSS, JavaScript, and Bootstrap files, which are important for this project, Appeal. And this is the templates folder in which we have HTML pages that are used in this project. It typically includes files like index.html, about.html, etc., which represent pages of the website. And here we have app.py file. So this .py file, it contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here we have Windows batch file. So instead of executing this project through command line interface, we have created this Windows batch file. And this is the database file in which database will be stored. So we need to double click on it to run that is to compile this app.py file. So double click on it, click on run. Here, if you observe, app file has been compiled. And after running this app file, the application will be hosted at the default address where we will be having localhost and the port unless configured differently. So copy this local link provided by the Flask framework and paste it in any web browser. I prefer Chrome, so I'll paste it in that. So we pasted the link. Now click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So here Let's click on get started. Before that, let's see what do we have here. So the first one is the home page and the admin login, which is a default person who will be monitoring all the activities. And we have option of Cloud VM user login. And before logging in as Cloud VM, we need to register as the user. So let's click on get started. So we need to create an account. So let's create account as user one and give the password and give the contact number. I'm giving a random number and then give the email address user1 at the rate Gmail. We have not given at the rate. Yeah, so it is gmail.com and give the address. So the address would be Hyderabad and click on create account. So user one has successfully created account. So let's see. Let's also register as the other user. Let's give it as user two and give the password. A random number I'm giving. And then give the address. Click on create an account. So now let's log in as admin and see what activity has been done in the cloud. So click on admin login. So give the username and the password of admin. Click on login. So here, if we click on view activities, admin will be able to view, or he can also click on view and block VM user activities. So let's click on view activities. So here, if you observe, these were the past records that has been in this application. And these are the two new recent records that has been created today. That is 2025 and time also we have when that activity has been done. So user one, the new user sign in has been, that is new user sign up request has been received and user two sign up request is received. So there are two activities. If he don't want, if admin will feel this to be unauthorized, he can also click on block. Now let's log out and log in as user one. Give the user one and give his password. Click on sign in. So he has successfully signed in and here he can upload the file and he can view and download the file and he can see the verification graph. So let's upload the file. So click on choose file. Let's get back. Let's upload this file. Click on open. And if you want file verification, he can enable that file verification. If else, we can uncheck that. So let's do the file verification. Click on it and click on encrypt and upload. So here, if you observe, file has been encrypted to save the cloud. So here, this is the file hash. It has been generated. Now click on OK. So click on view and download file. Click on view. So here, this user has uploaded the file. That is requirement.txt and this is the uploaded date and time and this is the file hash code and this file status, that is verification status, machine state unchanged. So this file has not been tampered with, so that is why it is showing machine status unchanged. And if we click on download file, user will be able to download it. So click on download. Here, if you observe, file has been downloaded. Now click on verification graph. So here, if you observe, on x-axis we have matching type and on y-axis we have computation graph. So this is the trusted and this is the untrusted computation graph. Now click on log out and click on admin to view the activity. So click on login. Click on new activities. So here if you observe user one, first he has logged in. So that is why it is showing user one login at request errors arrived. And then we have user login request successful. So first he tried to attempt login. Then next activity, it is showing whether it was successful or not. And then the next we have is encrypted file. So he has encrypted the file and then user one decrypted and downloading the file. So he was checking with his file. So that is why it is showing the other activity. If he finds any suspicious thing, he can block this user. Now let's click on log out and log in as user 2. Click on Cloud VM user login. Give the user 2. Give the password and click on login. So here also let's upload the file. Click on view download file. Sorry, before that let's upload. Click on upload file and click on choose file. So let's upload this file itself. Click on open. And now let's not do enable file verification. Now click on encrypt and upload. So here file has been encrypted with the file hash and it is saved to the cloud. Close it. Click on view and download file. And here if you see, this is the file owner. Here we have file name and this is the uploaded date and this is the file hash code. Here verification status excluded from verification. So here we have unchecked the option of enable verification. So that is why here we have the thing that is it is excluded from the verification. There is no verification needed for this. That is why he has excluded it. And if we click on download, he will be able to download it. Now click on verification graph. So this is a verification graph. Now click on log out. And now let's randomly log in as some other user. So click on user 3 and give the password and click on login. So here login failed. Let's try logging in as some other user. Just we are showing a sample fake case. So let's give user 4 password. Now let's log in as admin. So we have logged in successfully. Click on view activities. So here if you observe, user 2 has been requested for login and he was successful and he uploaded the summary.txt file. And coming to this case where user 3 has logged in, he was trying to log in, but his request was denied because he was not registered. So if this admin finds this user to be malicious, he can click on block. So let's click on block. And here you can see selected user 3 successfully blocked. Click on admin dashboard. And now let's block user 4 also. So here user 4 has also tried to log in, but his request was failed. So click on click to block. User 4 is also successfully blocked. Now click on log out. In this way, this project demonstrates a practical implementation of zero trust security in a local cloud environment by monitoring clients' machine states and ensuring file integrity through encryption and hash verification. The addition of user activity logging in further strengthens security by enabling the admin to detect and block malicious users. Overall, the system provides an effective and lightweight approach to safeguarding cloud services even without real cloud infrastructure. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.